me like a student, but I got it assimilated.
Wow.
All right, shall we get started? Let me show you something here. For every single joint here, you have to apply the constraints. Correct?
Yep.
It is so difficult. Let's just take a look at the constraints that's on there. Can you see that?
Holy crap.
Rigids and prismatics and cylindrical and level loops and planar and whatnot. And they all have to work properly. That's the toughest thing.
This you're honest.
You know, it might take a couple of seconds to get it done, or it might take several weeks to get it done. All right. I'll show you how to get it done in a couple of seconds. That's a tricky one, right?
Yeah.
Okay. Let's watch it. I tried doing it for the other class. Due to whatever reason, it did not work, but I got it here and working now. I'll show it. What you guys are doing is, I usually do this with a design, but I'm using it for you guys as well. I'm going to go and select the assembly first. I'm going to go to File, and I want you to go to, again, these drivers are carbon, and instead of going into the Catia, I have something called CAD customization. Okay? When you double click on that one, I have inline 4-cylinder fluid engine, right? So now, we're going to double click on that one. And when you double click on this one here, assuming that you have applied the right assembly constraints, that's why you should go back and analyze your assembly constraints. You should not overdo your assembly constraints, and if there are broken assembly constraints, you should get rid of that, because it will not work here properly. So you got to have only the right constraints as necessary. So once you're done, I have a block assembly DMU I'm going to open up. Okay, there are a number of assemblies here, but I'm going to open up the one which has _DMU, right? So you're going to open that up. All right. So we open that up. Right now, when I scroll down, there's nothing inside the applications mechanisms. If you go in there, there's nothing inside the joint. Can you see anything there? Nothing at all, right? Now what I'm going to do is, I have a command, magic wand right here. Okay? You see this one here? Assembly constraints conversion. It's called assembly constraints conversion. It might or might not work for you in your project. The reason being is you have wrong constraints. It's not going to work. Here I know everything is present. So I'm going to click on assembly constraints conversion, and then bring this up. And now what you do is, you want Catia to auto-create. Click on the auto-create icon. Done. What it says? 0 of 3100 solved errors. So all the constraints between the existing assembly constraints are converted to the right joint. It senses it and puts in the right joint. Then you click OK. It's done. Okay. That's the best part. Click on the joint, look at it, it's all in there, and then what you do, you just have to figure out which one to activate though. That's again, you know, a time-consuming task. I know that when I come all the way, you can double-click on one of these to find out which one is activated. That's not the one that you want. You go all the way down. Double-click on this rubber loop. See, look at that. That's what you want to get activated, right? So I'm going to say angle-driven, and let's say you can change the order. Click OK. Mechanism can be simulated. Click OK. I don't need the spectrum anymore, technically. So I'm going to move this over, and now what I'm going to do is to go back and click on the simulation command. Click on the simulation command, and then select mechanism 1. Click OK. You got 2 dialog boxes, which means it's going to work. So now you can just go to one end, click on insert, go to the other end, click on insert, and then change your installation step, rewind, and so that's fantastic. Mm-hmm. No, you couldn't do the simulation.
I know, but I couldn't do that.
I wouldn't say 8 plus. It's somewhere around 8. Not 8 plus. 8 plus is the product that I've shown you before. Those are all 8 plus. Well, this is again on top of it. It doesn't mean that just by getting full marks in your project doesn't mean that you'll get an 8 plus. Right? Okay, that's a project, yeah. Any other questions? Look at it. It's so simple to do it if you have the right constraints. There are further analysis that can be done. What you could do is you can go to Analyze and Mechanism Analysis. When you click on Analyze Mechanism Analysis, again, it will tell you whether the mechanism can be simulated, the number of joints, number of commands, degree of freedom. If you add way too many joints and constraints, then it's quite hard for you. Okay, so you can just open up the mechanism analysis and figure these things out. Another thing what you can also do is you can go to something called as editor. Okay, we have an editor here. See this one here? Edit sequence. What it is if you have multiple number of mechanisms. If you had multiple number of mechanisms, you may have to have, like, let's say, 2 commands. One rotating on one end and the other one rotating on the other end, but they are not connected. One multiple. If you have multiples, create individual simulations, and then in your edit sequence, what you do is all the multiple simulations are listed here. Then you can click one of these and move it over to this side, and then you can combine them. You can merge them. You can cycle them accordingly or according to a priority sequence, and all that is possible inside the sequential editor. Okay, right here, this is where you do it. You create a number of mechanisms, put it together, and then you can just run it accordingly. You can just hit play and it will work according to the sequence. You understand that? All right. So that's good. Let's go and try this one out. And then there's one more that I want to show you.